So we are going to be talking about vertical angles, which is section 2.8 in your book. And we're actually going to think past the partner think tank. And I'm just going to show you guys an example of what vertical angles are. Many of you guys are able to identify vertical angles already, which is great, but some of you are at that beginning stage, which is equally as great. So really those the vertical angles are formed by two straight lines, right? The angles, right, that are opposite each other, these are vertical angles. And their measures will be the same. They will be equal. So like these two angles are vertical angles. These two angles are vertical angles. And again, they have to be formed by the same two lines. And they have to be opposite each other. So those are basically the conclusions that you will make. In our theorem for proofs, we are going to write that vertical angles are congruent. That's it. So let's take a look at our first example. We'll include some additional information other than that, but let's first just start with our given. We are creating this paragraph proof, so let's first just create our logical flow of thought. So we are given that 2 is congruent to 3. So I'm going to mark that in my diagram. Okay, what else can we assume now that we have talked about vertical angles? Something else that we can assume is that we have vertical angles. We know 1 is in fact congruent to 2. So from that reason, or from that statement, we are able to make the conclusion that 1 and 3 are congruent because they have the same tick mark, they have the same measure. So that's the way that our paragraph proof will flow. So let's start with just first our given. We'll start with we are given that angle 2 is congruent to angle 3. Based on the diagram, we can conclude that angle 1 and angle 2 are vertical angles. We know that angle 1 is congruent to angle 2 because vertical angles are congruent. Therefore, and using the extra line, angle 1 is congruent to angle 2 or angle 3 by the transitivity of congruence. That's our paragraph proof. Cool. We're going to try a 2-column proof with similar information. I do want you to try this on your own. So go ahead, pause the video, write out your given, mark up that diagram, and then after you're done with it, unpause the video and check your answers. All right, go ahead. All right, and this is what your proof should look like, this 3 steps. Marking those vertical angles, and then creating that transitivity statement. Okay, the next one I'd like you to try is this review proof from 2.7. So again, mark down those congruent angles, and then I want you to prove that angle 2 is sup to angle 3. You will need an additional statement, right, other than these 2 steps. I'm thinking you're probably going to need 3 or 4 steps. Okay, probably 4. Okay, go ahead, pause this video, give it a shot. Okay, and I'm thinking that your proof will look like this, should look like this. We state our given, we need to state a straight angle before we're saying 1 is sub to 2. The reason we're doing that is because we can then use that substitution property to replace, right, angle 1 and angle 3 are congruent. We can replace angle 1 or angle 3 with angle 1. So again, this is the same exact statement. We're just replacing or we're substituting an angle 1 or angle 3 for angle 1. So that would be just our review proof for 2.7. Okay. The rest of these notes are more algebra, an algebra application. So you're deciding, hey, do I need to set these maybe equal to 180 degrees? Are they vertical, right? If they're vertical, do we have an x squared? Do we just have an x? Are we needing to solve for an angle measure? So with this algebra application, this will be really helpful for you to give it a shot, just to apply your vertical angle skills. Again, I do want you to pause the video and try these first 4. You're either identifying the vertical angleness, right, or you're identifying that those 2 angles form a straight angle. Okay, so go ahead, pause the video, give it a shot with 1 through 4. So these are your 4 setups for these problems. The only angle that's a straight angle was this number 1. So you would add both of those angles to 180 degrees because again, it's forming that straight line. Okay, for number 2, right, these 2 lines form the vertical angles, right? The V angles, they're opposite each other. That means they're the same measure. When you solve this, yes, it gets a little funky because it's a quadratic. But we move everything to one side. So we subtract the 6x, subtract the 20. In this case, we have 2x squared minus 6x minus 20. All I did was divide a common factor out of each and every term. I suggest you do that or check to see if you can do that if you have a value of a that's greater than 1. From there, we're finding the 2 numbers that multiply to negative 10. The 2 numbers that will add to negative 3, which end up being negative 5, positive 2, and then we set them both equal to 0. And then these other 2 are more simple algebraic, right? Getting x's on one side, numerical values on the other side. These next couple, we're going to do them together, specifically because number 5 can get a little tricky. Same thing with 6. Just with these diagrams. So with number 5, right, we are given this measure of 64. We're also given this measure of 36. 4x defines this entire angle measure. I'm just going to outline this angle measure of 4x, right? These are the 2 rays that create that angle. If I extend that line, right, I'm going to see if I can maybe find a vertical angle to that measure so I can set it equal to that. So in this case, this measures 4x. In this case, right, this is the vertical angle to that. So not just 64, but also 36, which will encompass that. So we have 4x is equal to 64 plus 36. Again, because they are opposite each other and they're formed by these 2 straight lines. Okay, we continue to solve. We get x is equal to 25. Okay, that's that. For number 6, we do have a little bit more complicated of a diagram. So let's take a look. So we have 3y, we have 10x plus 10, and we have y plus 60. So in this case, we want to first identify maybe some vertical angles that we can set up to solve this problem. Because if I'm thinking straight angles, right, we have 2 variables, and we might have to create some type of system to solve. But let's try not to set up a system. Let's try to think of some other type of equation. In this case, right, we're given this 3y defined by these 2 straight angles, or straight lines, or straight angles, right? So 3y is in this crook, then y plus 60 is in that other crook. This guy seems like a much more solvable problem because we have one variable we're dealing with, just a y. So let's set that up as is, subtract the y on both sides. We get 2y is equal to 60, y is equal to 30. Okay, but unfortunately that's not what we were asked to find. We were asked to find x. So in this case, I suggest just plugging y back into these angle measures. I'm thinking that might be able to be some type of help to us. So I'm going to plug in 30 for y into this angle measure. Okay, vertical angles are congruent, so I also know this angle measure is 90. Now, if we're thinking about our straight angle, right? Our straight angle is this guy right here. These two angles form that straight angle or that straight line. So our other equation that we can set up is 10x plus 10 plus, in this case, this measure is 90, is equal to 180. And then we continue to solve. And we get x is equal to 8. There are multiple ways that you can go about solving this, but the best way for you to solve it, or more efficient way, is set those vertical angles equal to each other and then continue on. Okay. So we, in this case, we're given that we have perpendicular lines, so we know that this measure here will be 90. In this case, this angle is talking about this smaller crook angle. This angle is talking about this one. We know that if one side of a straight angle is 90, one angle of a straight angle is 90, the other angle also has to be 90. So we can set up the problem 1/2 x plus 12 plus 3x plus 8 equals 90. And then all we're doing is solving this. 20 equals 90, x equals 70, and dividing both sides by 3 1/2. And we get 20. Oh, there's the line down here. And we get 20. Okay, so just make some conclusions based off the given information, which is exactly what we're going to do for number 8. So we know that 4 is congruent to 8. That's just what we're given. Okay, we also know the measure of 2 is 85 degrees. The measure of 6 is 5x plus 3 degrees. Okay, we can make some conclusions based off this diagram. We know 4 and 2 are vertical angles. They are congruent. We know 8 and 6 are congruent angles because they are vertical. So therefore, because 4 and 8 are also congruent, all 4 of these angles are equal to each other due to the transitive property of congruence. So therefore, we can set up the equation 5x plus 3 is equal to 85. We continue to solve and simplify, and we get 5x is equal to 70, and x is equal to, what is that? 14. And that is our information about vertical angles. So yes, you'll need to set some vertical angles up proof-based, but also algebraically dealing with quadratics, with transitive property of congruence, making conclusions about that. So that is that.